Good morning. Welcome back to Engineering 101. I've got a couple quick announcements, and then we'll get right away to our guest engineer. First of all, I'm not nearly as far in the grading of the short reports as I thought I would be. I find that I was overloaded with some other things, so I did a few this morning, and I'm going to keep working to catch up, and I'm confident that I will be all the way caught up at some point fairly soon, and you'll have all the feedback on your short reports. Keep them coming. I do have a pretty good stack right now, so if you're worried about whether I have them or not, I do have them probably. If it's in your outbox, then it's in my inbox, is the way the website works. And I've made some progress, but I'm not quite there yet. Sorry, I keep promising that, but I will come through, I'm sure. And then another announcement. This is for the UMKC students. I posted a couple documents on the course website. If you go to the course documents option, then I put it here near the top, UMKC Civil Engineering Program, UMKC Mechanical Engineering Program. These are new transfer guides. Let's see if I can open it up here on this computer. There it is. It lists the courses you take at the MCC system, at our community colleges, and then to the right of that, courses that you would take at UMKC years 3 and 4. That's for the mechanical and the civil. What kind of caught me off guard, I didn't realize we had so many courses here that you could take. That they list 74 hours worth of credit at the UMKC, or at our school, at the community college, and then a total of 126 hours, so that's 52 hours at the university. So that's for civil engineering, and there's a similar one for mechanical engineering. If you're looking at either of those, then please check out those documents. We're still working with UMKC electrical engineering. They have made more dramatic changes than mechanical or civil, so that document's taking a little bit more time. But as soon as I have a similar document for electrical engineering, I'll make that available. The UMR transfer guides, if you're going to UMR, they have theirs online, and I can help you find that if you don't know where to find that on the UMR website. But that's been out for a while now. If you have any questions about the UMKC documents or the UMR documents, I'm happy to talk to you about that. I'm fairly knowledgeable about the details, but even if I'm not familiar with your particular question right away, I'm willing to spend the time to learn about it because that's my job. It's one of the things I try to know is some of these transfer issues. I try to keep as up to date as possible so that I can advise students when they ask questions. A lot of times, we have advisors, but a lot of times students will ask me questions before or after class or send me an email with some questions about what courses they should take, and I try to know what I'm talking about. So if you have a question, please let me know, and if I don't know the answer, I'll dig around a little bit. And with that, we're going to go ahead and get started. I'm happy to introduce our guest engineer, Mr. Jesse Skinner. He is an experienced engineer with Missouri Department of Transportation, and he's working towards his professional engineering degree. So that would be a engineer in training. Is that the right name?
Yes, sir. EIT.
And I think you work in the maintenance division. You've had experience with testing, and you've been pretty successful, it sounds like, talking to you. You've had a great start, so I'll let you take it away, and then we'll fire some questions off.
All right. Like Dan said, my name's Jesse Skinner. I graduated from UMKC in 1999. I work for MoDOT. My job title is District Pavement Management Specialist. One of the things I want to say pretty early in the talk is I'm hoping everybody has some questions either about engineering in general or the life of an engineering student at college or what they can expect when they get out of college. I know I had a lot of questions when I started school, so at any time feel free to raise your hand or call in to the system and make sure that you ask some questions. I understand that everybody in this class is going to be an engineering major. I realize that some of you don't know yet which kind of engineering degree that you want to be. There's electrical engineering, chemical engineering, mechanical engineering, civil engineering, and some other engineering degrees you can get. Like I said, my degree is civil engineering. It's often not the most glamorous degree when you think of. A lot of people think high-tech, computer engineering, anything with the biotechnological field, automotive engineering. These are all things that we can conceptualize, and they seem pretty glamorous. But civil engineering affects us each and every day in a lot of ways that we don't realize. It's not until you go to cross a bridge and you can't get over it, or you go to drink out of the drinking fountain and you can't get any water, that sometimes you realize how much civil engineers impact your life. Civil engineering has a couple different disciplines that are all encompassed in the term civil engineering. Number one is construction engineering. These are the people that do things like estimate for construction companies or consultant firms, how much does it cost to do something. They figure out kind of the nuts and bolts part of building something. How do you build it? What sequencing should you build it? How many men? What kind of equipment you need? These are all things that construction engineers have specialized in. Another one that's a specialty is environmental engineering. These are the engineers that are able to remediate environmental disasters. They're the kind of people who design things like landfills, how to design new facilities for industry to where they won't damage the environment with their new facilities. Another subset of civil engineering is your water resources management people. These are the people that provide safe drinking water. They're the ones who can take a water source and give you safe water. They're also the people that can clean up either industrial contaminated water or household wastewater, and they're able to put that water back into the environment without hurting it. You also have urban planning. Urban planners are the subset of civil engineers that are able to look at things on a macroscopic level, and they determine things like how can an engineer improve the quality of life through things like congestion management, improving economic development for an area. Their goal is to basically improve the life of everybody on a very large global level. Then you have structural engineers. This subset of civil engineering deals with the structural details of how to safely and efficiently and economically build bridges, high-rise buildings, and other complicated structures. And then lastly, you have transportation engineers, which is my profession. Transportation engineers are the ones who are building your infrastructure like railroads, airports, harbors, highway systems, and the basic street system that everybody drives on every day. So, needless to say, all of those disciplines interact daily in your lives, and often we don't realize it. Excuse me. One of the things about engineering in general is it's very detailed. I'm sure that some of you who are starting your classes and you're starting to get through your calculus and your physics are getting to see that there's a lot of details. And I mentioned those civil engineering disciplines, but to talk about any of them until you get into your upper level classes and you start understanding the whys behind a lot of the details, they don't sound very glamorous. But I don't want you to just automatically discount them, because each of these fields, there is a lot of opportunity there. And like I say, they may not be as glamorous as some of the other kinds of engineering, but there's other things that are important in a profession than just glamour. So just don't automatically discount civil engineering. Before I get too far into talk, I graduated in '99. I'm not that far removed from my college experience, and I just want to give you a couple pieces of advice that either things I did while I was in school or things that I really wish now that I had have done in school. The first piece of advice I could give anybody who wanted to become an engineer is don't give up. Engineering classes are technical in nature. They involve a lot of studying. that involve a lot of time outside the classroom figuring out what is going on in that class. And almost everybody I knew in school had one class that was a little more difficult than another. And to become an engineer, it takes a lot more than just being smart. You have to have the dedication and perseverance to make it through the classes, especially the tough ones. When I was going to UMKC, there's more than one non-traditional student who had been going to school at UMKC for longer than I spent in high school and at UMKC. And that's a lot of perseverance to get through, but don't give up. If you want to be an engineer, not giving up is probably one of the most important things. Another thing is apply for all the departmental scholarships that you can apply for. There's industry scholarships and there's other private and public scholarships that are available for engineering students. If you go to a financial aid office, there's a whole lot of people that apply for a lot of the general scholarships in college. But the number of people that are eligible for engineering scholarships is considerably smaller. And play your odds and fill out every engineering departmental scholarship you can and try to keep your grades high enough that you're at least in the running for those scholarships because they really help out. Number 3 is take the EIT while you're still in school. For anybody that doesn't know, the EIT is the Engineer in Training exam. What the EIT allows, number 1, you have to have gone through an ABET accredited engineering school before you can take the EIT. And then in your last 2 semesters of school, you can take the EIT exam. Once you pass the EIT exam and you graduate with your engineering degree, most states it's 4 years later you can take the professional engineering exam, and that's the point in your engineering career that you're going to get a stamp that you can go ahead and seal plans and be legally responsible for the plans that you design. And a PE is a big step in any engineering profession, but I highly recommend that you take the EIT while you're still in school. There's a couple reasons. Number 1, if you take it in your second to last semester, it gives you another chance if you unfortunately don't pass it the first time. Number 2, it gives you something to brag about in your first few job interviews. If you go into a potential employer and you're able to say, I have my EIT, that puts you a step above a lot of the entry-level interviewees in the engineering profession. Number 3 is the EIT exam is very comprehensive of your whole engineering school career. And by taking it while it's still all fresh in your mind, it'll be a lot easier than taking the EIT after school. The people I work with, most of them, if they didn't get their EIT while they were in school, they have trouble getting it once they leave. It may take 2, 3, 4 tries, lots of studying, maybe even paying for an expensive review class. So go ahead and take your EIT while you're still in school. My 4th piece of advice is if you can get away with it, don't sell your engineering textbooks. I know that students are always short on cash, but you never know who you're going to end up working for or what kinds of engineering information you're going to have, and your engineering textbooks are really good background reference material. And my last and probably most important piece of advice is get some practical experience while you're still in school. In this area especially, there's a lot of opportunities for engineers of any discipline to get an internship, a co-op, summer work. Any of these is very important as an engineer. The first couple of years when you get out of school, if you don't have practical experience, your potential employer is often going to have to teach you their exact niche of engineering and what they need you to know to become a valuable and profitable engineer for them. So if you can get some practical experience while you're still in school, I highly recommend it. Personally, I worked for MoDOT one summer when I was in school. I worked for a private union contractor one summer as a union worker. I worked for Johnson County Public Works for 2 semesters. And the experience I gained from them gave me a really big foot in the door when I started interviewing. To be honest, my experience gave me more of a salary increase at the very entry level than if I'd had a 4.0 GPA. And a lot of firms and companies I talked to, they were interested in me not because of my GPA, but because I'd gone out and gotten that experience. And there's some other added benefits that you can get along with what looks good on a resume. Number one, a lot of people have to work while they're in school, especially if you go to kind of one of the non-traditional programs like UMKC. And engineering companies will pay you at least what you can make in a typical college student job. Number two, you are gaining that experience that's very valuable. And number three, a lot of the professional engineering firms offer tuition reimbursement. And you guys know how expensive college is. So these are all really good reasons to try to get some practical experience if you can. Any questions so far about anything I said? Sure.
The EIT and the PE are the same thing or different?
The EIT exam is now called the Fundamentals in Engineering exam, and the EIT is what you take as a graduate level engineer. The professional engineering exam you can only take after you get the required amount of experience working in your field. Not only do you have to have the experience, you have to have professional engineers sign off that you are experienced in the field, and you have to get letters of recommendation from both engineers and people in your community before you can take the PE exam. And so the Fundamentals of Engineering, or EIT test, is the first step, and then the PE is the second test that you take after you've gotten practical experience to go along with your educational experience.
Yeah, thanks.
You signed up for the PE soon?
I take the PE hopefully and pass it this month here in October, so I'm looking forward to it.
Excellent.
Yes, sir.
Sounds like maybe the fundamental test is all the same. Is the PE, or is it specialized?
Both tests, you have a morning session that's just general engineering information. And for the Fundamentals of Engineering exam, I was answering questions, some basic chemistry, some basic math, some basic physics, and then all your engineering classes that everybody has to take, your circuits, your statics, your dynamics, your strength of materials, all the classes that are required of all engineering degrees. But then in the afternoon for the Fundamentals of Engineering exam, you're allowed to either choose your discipline or you're allowed to choose another general with some more detailed questions. So, and like I said, it is a multiple choice test, typical standardized test that you're kind of used to taking. But when you get to the PE test, there again in the morning, it's more specific to your type of discipline specialty. You, in my case, it's transportation, but in my morning session, I'll take some classes in hydrology, environmental engineering, structural classes, along with some basic transportation classes. But then in the afternoon, it's very specialized to your discipline. So you're proving to the engineering community that you have the knowledge to become a professional engineer. So it's quite a bit more in detail. Yes, sir.
A standardized test like the block testing is?
The PE exam just recently in the last 5-6 years went to a standardized test. Before, it was all graded by hand and you got partial credit. Nowadays, it is a standardized test, and from my understanding, it's a little harder to pass.
I've got some questions for you, but I'm hoping that
Okay.
I'll be interrupted by people at Longview or Maple Woods or someone from home calling in. So feel free to interrupt me if you want to dial in. David will put you through. The first question is there, let me back up a second. It's been my impression that students tend to sort of float from some of the more exotic disciplines towards civil engineering. Is there is there some way that a student can know fairly early that civil engineering is for them? Is there some way that you knew or that other civil engineers know?
Like I say, civil engineering is so diverse that you can often, you don't know what subset of civil engineering you're interested in until after you get through all these basics. But once you're taking the basics, don't think just because I don't like statics or I don't like dynamics or strength of materials is hard for me that there's not a place in civil engineering. That's one of the reasons I become a civil engineer, is because it's such a diverse field and there's a lot of different niches there. If you like chemistry, chances are you'd like environmental engineering. If you like physics and you like statics and dynamics, chances are you would like structural engineering. Urban planning, if you've had some humanities classes that really interested you along with your traditional engineering classes, especially like an economics class or some business classes, urban planning would be interesting then. Water resources, again, is very heavily chemistry related in the beginning. If you like chemistry, chances are you'd like a lot of water resources. Geotechnical engineering, you really don't know whether you want to become a geotechnical engineer till after you get through soils and some of your entry-level basic classes. But like I say, it's a very diverse field, and it's a very, there's not enough civil engineers graduating from schools around the country. And I think for quite a few years, with the state of our infrastructure and with what the needs are worldwide, there's going to be a very big demand for civil engineers. Like I say, it's not necessarily the glossy, glamorous side of engineering, but it's a very necessary side of engineering. And because it's so diverse, that kind of gives you a lot of opportunities, whether it's starting your own small firm, working for a big firm, or a public agency. You'll find probably a wider variety of civil engineers employed in different jobs than a lot of the more specialized engineering disciplines. And the diversity goes a little bit beyond that. My day, no 2 days are often real similar for me. A lot of the time I spend in the field, but a lot of the time I spend in the office. And I like the fact that I can go wear jeans and work boots to work some weeks, but maybe when the weather's not so nice and it's cold and wet and snowy, I don't have to work outside. I can crunch numbers inside. I occasionally have to wear a suit and tie, but it's not mandatory every day. And that kind of diversity I also appreciate in civil engineering.
You mentioned that you were involved in the recent Paseo Bridge incident. You want to talk about that a little bit?
Sure. I'm not too sure who in here got impacted by it, but basically if you live north of the river, you discovered one morning you could no longer cross the Missouri River on the Paseo Bridge, and it made your commute to Kansas City a lot harder. It failed, I believe, on a Thursday afternoon about 4 o'clock in the evening. 7 o'clock Friday morning, I was out there with my boss, who was the ex-bridge inspection engineer for our district in MoDOT, and the state bridge engineer. And I was crawling around the bridge piers when we finally discovered exactly what had failed in the structure. And what it basically was is, with a suspension bridge, the cables that provide the structural support for the bridge creates uplift on the ends. And so you have to have these struts or hangers that create a downward force to keep the bridge from lifting up. And one of the struts, which was basically a bunch of pieces of plate steel that were riveted together, had failed along a line of rivets, and it could no longer provide the necessary force to keep the bridge down on its pier. So we discovered that. We led a pretty fast and furious contract with APAC, who was really good to work with. And normally our contracting process, it takes anywhere from 6 to 2 or 3 years in design, and then 10 to 14 weeks to review all your contract documents, which are some pretty technical legal documents, and then let a contract to the lowest bidder to do the work. In this case, for the structural repairs, we notified all the contractors to show up the next day on Saturday, and they came in, and in one day we'd created a contract, and we let it, and we had some really good contractors bidding on it who they didn't even know when they went in that morning what they were bidding on, let alone be able to get a good estimate like you would normally do as a good contractor in the process. And so APAC got on it right away. We had some really good suppliers that worked with us, custom fabricated parts on a very short notice, did a lot of custom machining for us. And then at the same time, what I was more heavily involved with than the original structural contract was, number one, coordinating our maintenance forces. If you're familiar with the area around the Paseo Bridge, it's a very busy place. It's hard to create a lane drop to do any kind of maintenance work in the area, and it's dangerous for both the public and our workers, and there's considerable cost involved. So I helped coordinate a lot of the maintenance activities that were going on. We had a very concentrated maintenance effort that did a lot of maintenance activities that weren't able to happen in the last 5, 10, 15 years in that area just because of the very high volume of traffic. And simultaneous to that, they had me try to figure out how much work our forces could do as far as repairing the bridge. Anybody that had driven over it knew it was pretty rough. There's lots of patches. The wearing surface of the bridge was very rough, and we took the opportunity we had there to let an emergency contract to repair the bridge wearing surface, and I was pretty heavily involved with all of the asphalt work that happened on that. So it was not a typical week, but I guess what that's emphasizing for me is no real 2 weeks in my job are very similar. What I do is very, even though I'm a transportation engineer, I spend quite a bit of time with our planners prioritizing what work needs to be done. On a very global scale, we have a very large network, and to manage it efficiently, you have to determine how long can you get life out of something and what needs to be fixed right now. So I work quite a bit with our planners. Another subset of civil engineers that I work with quite a bit is our construction people. Often they'll have problems on a job site, and if I'm able to, I'll go out and I'll provide some technical experience as far as what's going wrong, or maybe even do some lab testing. I was originally hired on in MoDOT in the materials division, so I had a pretty big hands-on testing background. Normally I don't do a lot of testing, but I still go out there and help troubleshoot some problems. Some of the other engineers that I work with quite a bit are designers. There's a lot of questions that come up in our new designs, and I spend quite a bit of time either A, going out with designers and showing them what's wrong with the current roadway system, or I help them with our new pavement designs as far as what they need to include in their designs for our new designs. Some of the other people I help are our maintenance forces. For quite a while, MoDOT hasn't been able to maintain our roadways probably as good as I think we should, and part of my job is improving some of our maintenance practices to improve the life cycle of our roadways. Yes, sir. Sure.
How come, like, in the new construction, they're now using cement on the roads?
Actually, to be honest, concrete is actually what I like. Cement is the cementitious material that binds everything together, but concrete's the term we like to use, and concrete's actually a pretty old construction material. The Romans were using it over 2,000 years ago, and it's not necessarily a new material, but it's often an expensive material for us. So we
I'm not sure I understand the question, though. When
You're asking why you see so much new concrete as far as asphalt? As compared to
Yeah,
asphalt?
now they're starting, all the new roads they're building is becoming more concrete than asphalt.
We're building some new asphalt roads, but when we originally built our interstate system, it was almost predominantly, at least in urban areas, concrete. And when you see new roads go in, they often go in concrete. We get a lot longer life out of our concrete roads, but often what you don't realize is you're driving down a road with a black surface on it, asphalt, and a lot of times that was a road that was maybe built in the 1920s or 30s, and starting in, say, the 50s, 60s, 70s, we started overlaying that concrete with asphalt. And so a lot of the roads you drive on actually were originally concrete roads that, for economic reasons, we just resurfaced with asphalt in the meantime. But we do build quite a bit of new concrete, but like I say, it's fairly cost prohibitive.
Thanks.
Anytime for any transportation questions, like not necessarily what I do, but how come I get stuck at a stoplight, or why is there all these orange barrels? You guys drive through work zones and you drive on the system every day. Surely there's some questions just about that. Yes, sir.
All these new flying overpass type construction that we've got going, like out at the Triangle, why are they allowing those roads to stay so fast and not pitching any bank into them, so that when you drive around them in a truck, you almost fall off of them?
The term you're referring to there is super elevation in the roadway, and there's pretty stringent design criteria that the Federal Highway Administration and each state agency has as far as super elevation. And what you have to balance there is not only enough curve to keep you on the roadway, but you also have to be able to, at least in the Midwest, in our area, in the wintertime, you're guaranteed to get rain, and then it's guaranteed to get snow and ice. And once you get a real slick pavement, you have to have a flat enough curve that if a slow-moving vehicle, say it's going 20, 25, 30 miles an hour, it doesn't slide off to the inside of that curve also. I'm sure the Grandview Triangle in your question was designed probably for a 65-mile-an-hour design speed. And like I say, it's both federal and state guidelines that they're designing those curves to. But they're trying to create enough acceleration to keep the vehicle from flying off, but they're also trying to keep it from falling to the inside. So like many other things in engineering, it's kind of a delicate balance. And a lot of what you probably are feeling isn't necessarily the curve, but some of the other geometrical designs on the ramp that kind of just gives you the feeling of going over, even though probably the radius of curvature is probably well within the guidelines.
Well, I know when I drive a roll-off container truck and those things are loaded, it'll pull you right over, and you don't have to go that fast out there. It's flat. There's no pitch on them.
I understand. It's pretty nervous also in an overloaded snowplow.
Yeah.
Which that's one big thing that MoDOT provides is in the wintertime, winter operations as far as dealing with the weather, and that's something that even our engineers will get involved with, is getting in a dump truck that's probably way overloaded by DOT regulations and going out there. And I understand what you're saying, but like I'm saying, it's some of the other geometrical design features there that kind of give you that feeling.
I visited MoDOT a few years ago, and they showed us some software that you use for traffic light planning. Mm-hmm. That was pretty impressive. It had all the timing all laid out, so you could figure out how the different cars how long they'd be stuck at each light, or whether they'd be able to cruise right through or whatever. It had the red, yellow, green labeled with versus time, and that was kind of interesting. Do you guys use that a lot?
The people in our traffic engineering department use that quite a bit as far as traffic modeling. Our planning department also use it as far as determining some congestion issues. But there's a couple different ways you can actually do traffic signals. You can have everything pre-timed, where it's a set time that you have so many seconds between at this intersection that traffic traveling a certain direction can travel. You can have actuated traffic signals where you have either a loop in the pavement that magnetically detects your cars, or you can have a video camera that detects it and sends a signal back to the computer that tells the traffic signal in so many seconds people in this direction need a chance to go this way. Or you can have what they call semi-actuated, which is in between the two. And at different times of the day, it'll work one way or the other to improve the flow of the traffic. It's kind of how that works. Yes, sir.
Yeah, my father, he used to work for the transportation department, and I saw that program that Justice Dan was talking about. It's pretty neat.
Yeah. If you actually get a chance to see the software, it looks like a bunch of little ants moving around the screen, and it's kind of a high-tech engineering version of like a SimCity simulation, and it's pretty interesting for the people who get into that subset of civil engineering.
I asked you earlier before class about environmental impact studies, and you shared a little bit about that detail. I thought that was interesting.
Environmental engineering touches every project we do, in that it's both a federal and a state requirement that we get an environmental impact study done on any project we do. And it looks at a couple different things. Number one, if you have any natural resource features in the area, say a river, a stream, a lake, it looks at what is your construction site going to do to that, and what things does your project need to include to mitigate any kind of damage that you could potentially do. Another thing that they look at is endangered species or wildlife in general, and they kind of determine what kind of impact is going to go on, and if any kind of special staging of the operation or any relocation of species or anything like that has to go on to protect the wildlife. And then finally, it looks at the site from an archaeological perspective, and they try to determine if there's any known archaeological sites in that area, and are you going to be impacting, say, an Indian burial ground, a historical 1830s settler dwelling or something. And all these we try to figure out up front, because if you discover any of those three things in the middle of a job, it makes your job a lot more expensive and a lot harder. We recently had a job on 150 that in the middle of the job they discovered a pioneer family's burial ground. And when we dug up these human remains, the first thing that we had to make sure is, A, it wasn't a crime scene, and B, whose bones were they so they could go back to the proper place. If it's a Native American remains, we try to find out the proper tribe and return it to the tribe so they can take care of the remains in their tribal manners. Or if it's somebody who's immigrated to the country, we try to give them the proper respect and a good burial when we have to relocate their remains. So there's that. That just goes back to the diversity. It's such a diverse field that you can't just be in a niche if you're a civil engineer. You interact with all kinds of different professionals.
When over time you've probably known either some fellow students or maybe coworkers that have left MoDOT to go to work for a consulting company or for some kind of a construction firm. How do you feel working for the government compares to maybe those kind of jobs?
I'll say that when you get whatever job you get, nothing's free. Everything kind of comes with a trade-off. Number one, there's a little bit of market volatility involved. I had a couple friends that went to work in the private sector, and one of them was downsized pretty quick last year, unexpectedly. I knew some other people in a different engineering firm that they went in there the day before Christmas, and they were told that they didn't have a job after the first of the year. And engineering usually isn't as volatile as a lot of the other core job markets, but there is a little bit of volatility there. And usually if you're in a public agency, you're a little bit protected from that. There's also all sorts of trade-offs, private versus public, things like benefits. On the private side, you're typically going to be working quite a few more hours a week. My wife worked private for 2.5 years before she went to a public entity. She was basically required to work about 52 hours a week. Sometimes I work 50 or 60 hours a week myself, but the nice thing is I don't have to do that every week, day in, week out, year after year after year. I have a lot of flexibility in my work hours that if you're working for a private consultant, you lose some of that flexibility, and it's a lot about getting a job done on time. And you also have different benefits that, like I say, everything's kind of a give and take, a little bit with money and benefits, but it's a little different being a private or a public engineer. And I'd advise everybody not to discount either, because there's a lot of opportunities out there in both. And don't just automatically assume I have to go to a private engineering firm to make the most money, because that's not always the case. And don't assume that if you want the best benefits that you have to go to a public entity either. Like I say, there's a lot of opportunity, and make sure you shop around on some of that opportunity.
Good.
Yes, sir.
The government, I mean, where else can one get a job as a civil engineer?
A lot of places, believe it or not. Construction companies, a lot of their estimators, a lot of their project managers, a lot of even their management of a construction company are going to be from an engineering background. So you have all your construction industry, you have all your consultant firms. Typically, a public engineering entity isn't going to do all their design work. They simply don't have the resources to do it, and they're going to contract out a lot of their engineering work as far as plan development, getting a set of plans ready to let a job. They're going to have to let a lot of that out to a consultant firm. Then you get things, consultant firms deal not only with public entities, but consultant firms are also going to do engineering work for school districts, for city governments, for businesses. If you're, with today's job market, a lot of places can't have an engineer on staff, so they rely on a consultant engineering firm to provide not only, like I say, the plan development, but they're going to hire an engineering firm to inspect their construction work as it goes on and to manage their construction contracts. So if you have all your consultant engineers, you have all your construction company people, you have people with public entities, then you have some places that you wouldn't really think. A lot of industries sometimes find it's valuable to have an engineer on staff if it's a big enough business to support that kind of resource demand. They have engineers on staff just to help them improve their products. And it doesn't necessarily have to be a manufacturing engineer or a mechanical engineer. A lot of them have civils that work in the environmental side or the structural side. Yes, sir.
I was going to say, in most careers, you can expect every 2 to 5 years to have to change your job in order to advance. Is that seen as much in engineering, or do most engineering firms try and keep their brain trust tight and advance to keep them?
Engineering offers you a lot of opportunities. Some people, to get ahead, they'll move between companies and corporations and public entities quite often, and they'll move around and they'll work their way up the career ladder there. But you don't necessarily have to do that. Engineering, there's a lot of opportunities within one organization to work your way from the bottom entry level all the way up to the top. Another thing about engineering is once you get your degree and your professional engineering stamp, you can go out on your own and start your own company. So you do not have to move around. I'm not too sure what the average is now, but a lot of engineers, I'd say, probably move in that 5 to 7 year range. But the reason they're moving is all the opportunities. And like I said, a lot of them are starting their own firms, which there's a lot of industries that you just can't get a degree and go out there and start your own business.
How much time does the average engineer at MoDOT spend running other people's work, like handling contracts and bidding process, versus actually doing the design work themselves?
The way MoDOT's structured, we specialize in some different, what they call departments or divisions. And you have a design division that mainly does project development. They do plan sets and everything. And they spend the majority of their time, probably 90% behind a desk, crunching numbers, working on a computer, drawing things, calculating things. Then we have both construction and materials engineers that spend probably 65 to 85% of their time in the field and the rest doing paperwork in the office, who they're just hands-on engineers. They're out there at a project level making sure what's happening is the right things. Then you have traffic engineers who are probably split a little closer to 60-40, 60% in the office doing traffic studies and traffic analysis, and maybe 40% of their time out in the field. Then you have, personally myself, I probably spend about 35% of my time in the field and about 65% of my time in the office. My time in the office, I'll either be spent analyzing data as far as payment conditions, or analyzing potential budget scenarios, or helping design or planning with their jobs. And the time I spend out in the field is either troubleshooting or some more data analysis kind of type functions. So either way, there's always, if you're a civil engineer, there's opportunity to get out of the office if you want, and there's opportunity to stay outside all the time if that's what you really want to do.
Okay. Any other questions? Okay, well, we're about out of time here, so let's thank our guest engineer. Thank you, Justin.
If anybody has any questions about engineering careers, or what they can expect, or what typical interview questions when they go to their first job interviews, or what kind of money they can make or anything, feel free to give my email address out to the class, and I'll be happy to answer any questions I can.